lastly, let's look at the last one. So it says use a calculator to verify. You guys know how to do that now. You're just plugging into the calculator. So you plug in the equations into the calculator and then verify algebraically. And again, remember, this will be my first equation. This is my second equation. When I graph the two, we'll put them in different colors, and you make sure when you type them into decimals, you get the exact same graph. All right, I would say use parentheses when you plug them in. Okay, so again here, I don't see any side left or right that looks more complicated. So we get to kind of pick, right? So I'm just going to take the left side and prove that it equals the right side. So we have cotan alpha and then over cosecant alpha minus 1. So the only reason I wouldn't change everything to sine and cosine is because there's no sine and cosine here, and then I'd have a little bit more work to do. You can do it, it's just going to be a little more use of your sheet of paper, right? It'll give more steps that you'd have to do. What I'm going to do is take this denominator and use the conjugate to rewrite it so that hopefully I'll get a Pythagorean identity that I can use to change this to a cotan. Okay, so I have cotan on the numerator over cosecant minus 1. I'm going to multiply that by cosecant plus 1. All right. And so we're still on the left side here. So if I multiply here, I could use FOIL, but that might kind of cover up some of the identities that I can use or some of the simplification that I can do. So I'm just going to leave it in the factored form. On the numerator, I'm just going to put cotan times the quantity of cosecant plus 1. Okay, so just put these together without foiling them. Helps when we simplify in the end. And then here again, I'm multiplying by the conjugate, so I know that I'm going to have cosecant squared minus 1. The middle terms, again, if you need to FOIL it out and see, the middle terms will cancel out. But anytime we multiply by the conjugate, that always happens. Middle terms are exactly the same, but the signs are different, so they cancel out, and we just end up with the first one squared minus the second one squared. Okay. So then I look here, there's not much I can do. I don't see any identity up there. There's no squared. Here, there's an identity, right? I have cosecant squared alpha minus 1, which if we go back to our trig identities, we can rewrite, we don't have to rewrite. We can look at the Pythagorean identity and see, oh, this is just cotan squared. So I'm going to rewrite this as cotan squared alpha. Just going to put here a little note. This is cotan squared alpha. Oops, don't need anything else. So, numerator we didn't do anything with, so we're just going to rewrite the numerator. Denominator, now we're changing to its equivalent form, which is cotan squared alpha. Writing it as cotan alpha, that quantity squared, or cotan squared alpha is exactly the same. So you can choose how you want to write it. Now I can see some simplification that I can do. I have one cotan here. I have 2 here. So I'll cancel 1 on the numerator, 1 on the denominator. And then I end up with exactly what I want. Cosecant alpha plus 1 on the numerator. Cotan, just 1 cotan alpha on the denominator. That's exactly what I was looking for. So now I can say we have proven the identity, and the left and the right side are exactly equivalent. Okay, so go ahead and try some more identities and see if you have any questions.